There are many reasons why wars are won. When you have the biggest and deadliest killing machines, it really helps.
When you want to make a big impact, you need maximum firepower.
There's nothing to clear but the munitions and the bodies.
There's no place to hide from this cave-busting bomb. It's one of the world's most powerful munitions. The Iraqis call this rocket Steel Rain.
The enemy just trembles.
And I'm about to see it unleashed.
Normally, this isn't a place you want to be.
I'm Richard Mackles, and I spent 10 years as a Navy SEAL. I thought I'd seen everything, but there is a new generation of big, brutal weapons out there which will create maximum impact on the battlefield. MLRS. It's military shorthand for Multiple Launch Rocket System. A whole family of launch vehicles, rockets, and missiles. It's designed to hit targets that ordinary cannons just can't reach.
The first missions we shot were between 60 and 65 kilometers.
It was initially deployed during the first Gulf War, when military thinking favored high-volume attacks covering as large an area as possible. The original MLRS rocket was unguided and carried hundreds of individual bomblets, which caused damage over a huge area. Because of this, the Iraqi troops soon gave it the nickname Steel Rain.
MLRS was defined in Desert Storm. I mean, Steel Rain. I mean, it's instant surrender. Don't even fire at us.
But the changing needs of modern warfare means that technology has to adapt. Today, precision is the name of the game. And here at White Sands Missile Range, preparations are well underway to test the very latest addition to the MLRS family.
How long has this system been around?
The Guided Multiple Launch Rocket Systems have been around only for about 5 or 6 years, but it traces its history back to the original Multiple Launch Rocket System, which was developed in the early 80s. The accuracy was limited, and it was an area munition. And after the first Gulf War, we learned some lessons from that. And one of those big lessons was that we needed munitions that had better precision, able to attack point targets with good precision. And then so that started us on the path towards development of the Guided Multiple Launch Rocket System.
The weapon is guided because it uses GPS to pinpoint its targets at ranges of over 50 miles.
The military has access to more accurate GPS than, say, the civilian. Consequently, we can fire these rockets very accurately.
It limits the collateral damage. It has incredible pinpoint precision.
And it carries a single high-explosive warhead to focus all its destructive power on just one spot.
It's able to defeat the targets and be lethal, but limit the damage to the surrounding areas.
You know, you can basically hit a target and not take out the buildings around it.
We know we kill it if we hit it.
An earlier version of this rocket has already completed its testing phase and proven itself highly successful in combat.
Right now, they're fielded to Iraq. We had an urgent need from the Iraqi theater, and so we hurried into production to get these rockets over there.
The current version deployed in Iraq detonates on impact and has a delay mode for underground targets. But this is White Sands, where only the very latest cutting-edge weapons are tested. And this version has yet another method of destruction. The airburst, where the missile detonates just 30 feet above the ground.
The rockets that are currently fielded in Iraq do not have the airburst fuse mode.
Right.
So this is a new test for them, and it will be fielded soon.
The airburst gives us capability to attack a wide area target.
What kind of damage will we see on the target site?
Well, I think the results will be evident tomorrow. You know, you're going to get to see the before and afters, but I think you'll see devastating effects on target.
I decided to visit the test site so I could really judge the missile's true power. White Sands is the largest military installation in the United States, so just to see the target area, I had to hit the road and drive over 40 miles. I left the launch pad and have been on the road for 30 minutes. I still have probably 15 to 20 minutes to go. The rocket will make that same journey in less than 120 seconds. 45 minutes later, I finally reach my destination. An eerily quiet location in the middle of the desert plains. It feels like the calm before the storm.
I've been granted access to this impact site. Normally, this isn't a place you want to be. As you can see, these mannequins are numbered all over. That's so after the test, they can identify all the pieces.
The mannequins and the field gun are the target for the airburst test, where 3 rockets will explode above the ground in a shower of deadly fragments. But just a few hundred feet away lies the second target designed to show the devastating effect of the rocket's delay mode in taking out underground targets. This bunker complex is effectively an enemy command center complete with a half-dozen chambers leading off a central corridor. A structure this solid would normally offer adequate protection from small arms fire, mortars, and even light artillery.
This is an extremely elaborate, entrenched position. I'm really curious to see what the missiles will do to this target.
There's about an hour to go before the first launch. The vehicle is now loaded with live rockets.
You can see in the background what's going on behind me. They're actually loading the real rocket pod. It's conditioned hot, and there's live ordnance on the pad.
The rockets are treated with the greatest of care as they're loaded into the launch vehicle. The munitions also go through an extreme testing process that simulates arduous battlefield conditions.
They have seen a life cycle of use and abuse.
It's all the tactical vibrations, all the transportation shocks, all the temperature extremes that you'd see.
We beat them against the wall. They've been baked, frozen. We strap them down to a giant paint shaker and shake them for several hours, which simulates a lifetime of riding on the launcher.
You know, the test didn't start just today. The test has been going on for 6 weeks.
Coming up, I witnessed the awesome power of the MLRS missile.
That's one of the coolest things I've ever seen in my life.
And still to come, the gun that can fire off 1,000,000 rounds in just 1 minute. Don't mess with Metal Storm.
70, 60, 50.
The countdown has begun, and in just a few seconds, the first of the rockets will be on their way to the bunker site.
2, 1, fire.
That's one of the coolest things I've ever seen in my life.
As soon as the smoke from the first launch has cleared, a second one tears across the sky.
We're good? All right. 2 away. All right, 1 event on the ground.
The bunker is finished.
It's got that pinpoint precision that just hits the target. So I mean, we're not talking about just hitting a building now. We're talking about hitting, you know, the west side room in the corner of that building. The guys love it. The soldiers, they absolutely love this system. It's a powerful weapon, and just to see it fire is an amazing thing.
I've been doing this my whole career, and I wouldn't have had it any other way. I love this system. I've loved it since I joined the Army, and I still love it to this day.
Fresh from a tour of duty in Iraq, these soldiers from the 13th Field Artillery belong to the 1st Army unit to field the guided unitary rocket.
This bad piece of machinery. Just watching it fire is an awesome thing just to see.
The psychological component is big, too.
I don't know that there's any other system out there that provides no warning. There's absolutely no warning. Once he's targeted, the next thing he hears or doesn't hear is the explosion.
At the launch pad, it's almost time for the second set of test firings. This time, 3 rockets have been programmed for airburst mode, which should explode just off the ground.
It's flying up to 69,000 feet.
The data and images coming back from the targets indicate the tests are a resounding success. But the only way to totally be sure is to see it ourselves.
How'd it go?
Look for yourself.
Look for myself. All right.
Absolutely.
First, the airburst explosions. It should have rained down tons of shrapnel on our mannequins. What's amazing is when you look at this impact area, how little damage there is. I mean, it's very specific. You got a burst that comes up about 30 feet in the air, comes down and rains down metal right on the targets it's supposed to hit. You look around, there's very little damage at all. It's a very precise, very lethal weapon.
They're all three shots all close within this area.
Okay. I mean, this guy's no longer with us for sure. I mean, just the blast pattern alone. I mean, if anybody's even lucky enough to survive,
there's heat and pressure along with the fragmentation that gives us the full effect. For instance, this one mannequin doesn't have any fragments on it, but it's unlikely he would survive the attack.
Yeah, just the pressure on the eardrums, the sinus cavities, all those places, just collapsing. Needless to say, this artillery position is no longer functioning.
Certainly the people aren't able to operate it, and there's some good damage to the artillery piece itself, too.
And as for the bunker?
Bunker looks nothing like I saw it yesterday.
No, it's very changed.
I mean, there were rooms, there were separate areas. Wow. You know, there's part of me that I love explosives, you know? But this is the hard, cold reality that anybody inside this area, it's over.
Yeah, it would have taken a lot of smaller munitions, a lot of effort to get at this. But with two of our rockets, you can see it's pretty much out of commission.
It's finished.
I've never seen a weapon that travels 50 miles and hits a target within 10 meters.
And you can see that really this is not that large of a target, and we put 2 rockets on here at 2 different specific locations. That's how accurate we're aiming. It gives you great lethal effects right where you want them to be, but it doesn't, it contains those effects into a close area and doesn't cause any collateral damage outside that area where you want the effects to be.
Absolutely. I'll tell you, you wouldn't want to be inside this bunker right now. Well, it'd be over.
Absolutely. The soldiers are out there doing tough jobs, and the guided MLRS has long range, and so they're able to, the soldiers are able to operate in safe areas, but yet still accomplish their missions with the guided unitary.
It's a very highly maneuverable supersonic missile, 0 to Mach 3.5 in about 8 seconds.
It's basically employing a ground-to-ground missile system that now the Army is able to use too, and being able to have that capability is really can turn the tide in some sort of conflict.
These guns may soon be obsolete because a new baby's on the market that can fire 1 million rounds in just 1 minute. And later, the bunker buster that creates maximum impact. Nobody's going to argue that a machine gun that can fire 1,000 rounds a minute is anything but lethal. But the gun is old technology. It's been around for centuries.
It goes back to the 1500s, the way we built our first weapon.
Since its invention, the mechanism that fires a gun has changed very little. As a former Navy SEAL, having the right gun on the battlefield makes all the difference. But with seriously sophisticated weapons appearing in modern warfare, it's time the good old gun got a major revamp. And that's exactly what the guys at Metal Storm have done, and then some. Imagine a gun that fires over 1 million rounds a minute. Now, picture a gun that fires a 40-millimeter grenade at a rate of 4,000 rounds every second. And what you have is Metal Storm.
We've been told that we're the greatest advance in weapons technology in the last 200 years. You don't need a bolt. You don't need a firing pin. The only moving parts in these guns, as in all Metal Storm weapons, is the projectile.
Metal Storm is the most lethal, destructive automatic gun in the world. It can decimate advancing armies and rip missiles to shreds. So, how has this terrifying weapon rewritten the rulebook when it comes to guns? The answer lies in its revolutionary firing mechanism. Traditionally, bullets are stored in a magazine and are mechanically loaded into the gun barrel.
What makes Metal Storm so unique and unlike anything that's ever come before is there's basically only one moving part, and that's the bullet.
Metal Storm's revolutionary design lies in combining the barrel with the magazine. The bullets are preloaded into the barrel where they are lined up behind each other, so it can fire at a much faster rate. And these bullets are different. They're fired using an electronic ignition system. At the touch of a button, a series of electrical signals are sent down the barrel to the bullet. The bullet is then ignited and fired out of the barrel. I went to Washington, D.C. to meet some of the brains behind the project.
The basic Metal Storm concept, as you know, is the barrel is the weapon. So basically, if I wanted to, this could be a Metal Storm weapon. Push a button, fire it, you know.
Art Schatz is vice president of Metal Storm, the designers of this groundbreaking new gun.
Because the weapon is electronically fired and the rounds are stacked, you've either got a lighter weapon or you've got a weapon that's the same size and weight, but yet it's got a tremendous amount of firepower.
General Downing was the head of the Joint Special Operations Command and now advises on the project. By using an electronic ignition system to fire the bullets, Metal Storm has made the most powerful handgun in the world, and the fastest. Firing 3 rounds in a split second before the gun recoils means the bullets can be delivered with deadly accuracy. The electronic firing system has one further advantage. Unlike conventional guns, this system can never jam. In a firefight, gun jams can be life-threatening, leaving you exposed and helpless in the face of the enemy.
The malfunctions that I've had in training, and I've had malfunctions on a battlefield. In fact, I've almost been killed. The kind of things that happen are a firing pin breaks, a bolt goes off the slide, a recoil spring breaks. With that all-electronic weapon, you're not going to have that, so you're going to have a high degree of reliability.
The worst thing that can happen, if a signal doesn't go off, the following round can push the first one out. So you don't have the typical jamming effect of a feeding.
Because you don't have the moving parts.
There's no moving parts except the projectiles themselves.
By removing the mechanical firing mechanism from the weapon, the designers have not only made Metal Storm reliable, but also the most powerful automatic gun in the world. Metal Storm can fire a devastating hail of bullets in 2 modes. It can unleash a stream of bullets, effectively making an airborne supersonic metal spear that's able to pierce through armor. Its second mode is an unstoppable wall of deadly bullets, fired out of multiple barrels. It's this unprecedented firepower that has created the kind of weapon never seen before on the battlefield. Using 9mm rounds, Metal Storm can fire 16,000 rounds a second through multiple barrels, creating a wall of bullets that can intercept an inbound supersonic missile in a split second.
You could take these same Metal Storm weapons and you could use these things to detonate mines or perhaps even incoming torpedoes. So it has a tremendous all-round capability.
But Metal Storm is capable of so much more. Replacing bullets with high explosives, it can fire 40mm grenades at a mind-blowing rate of 250,000 rounds a minute. A wall of these high explosives will flatten buildings and crush hardened concrete bunkers for maximum impact.
And where we've gone, finally, in our latest firings, we're taking actual off-the-shelf existing warheads and marrying to the Metal Storm launcher piece.
Metal Storm can now deliver these warheads with deadly accuracy. It can obliterate a whole battalion of tanks and armored vehicles within seconds. But this weapon is as sinister as it is deadly. Metal Storm doesn't even need to be manned. It can be left completely unattended, a silent assassin waiting for its prey. Its sensors can detect anything that approaches.
One of the things that our sensors give us is they give us much more battlefield awareness of what's going on around us.
Metal Storm's sensors feed back valuable intelligence to battlefield commanders. The generals call it situational awareness.
Situational awareness is where's the enemy, you know, not just the one in front of you, but where are the other guys who might hit you in the flank, then where are my guys? And how can I conduct this operation to put maximum hurt on that enemy?
Acting as a guard and strike force rolled into one, it can protect soldiers from surprise enemy attacks. It's a silent assassin waiting to strike. And with its deadly pinpoint accurate fire, it can obliterate any opposing force. Far from being stuck on the ground, this lethal weapon can be adapted to fit on any combat vehicle.
This thing can go on anything that you can think of, because the only thing that you need is a tube to stack those rounds in, and you can literally put it anywhere.
From any ground vehicle to ships and all kinds of aircraft, there's no place Metal Storm can't go. And on the battlefield of the future, it'll network with other intelligent combat systems. It's both super smart and super deadly. Still to come, the cannon of the future.
You know, there's a reason why we are called the King of Battle.
The greatest threat posed to enemy ground force is still artillery fire. That's why cannon artillery like the Army's howitzers still play a key role in today's fight on the battlefield.
Although today's self-propelled howitzers are quite impressive, they do have a problem. With a combat weight of over 40 tons, they're heavy. They lack a certain speed mobility on the battlefield. Plus, they have to be manually loaded and fired, and that takes a lot of muscle and manpower.
To get a glimpse of the future, I'm on my way to Yuma, Arizona, home of the U.S. Army's testing ground. It's 1,300 square miles of desert and the perfect place for letting off a few artillery rounds without disturbing the neighbors. I've got special clearance to witness the testing of the artillery's newest weapon, the non-line-of-sight cannon, also known as the NLOS cannon. It's fast, it's light, and it's intelligent. It's part of the Army's future combat system. Nothing like it has been seen before. It's so new and revolutionary, the NLOS cannon is still in its early stages of development. The top brass of the U.S. Army want to see the future happen today, and that includes Colonel Tanzi, who's responsible for the Army's entire artillery program.
This is the non-line-of-sight cannon. It's a lightweight, highly mobile howitzer field gun designers have made fully automatic. It can fire a 100-pound round every 10 seconds, and it can take out targets up to 16 miles away, all with the push of a button.
And it's this automated loading and firing that gives the NLOS cannon its incredible firepower. The soldiers load up as before, but then the automation takes over. To understand how revolutionary it is, here's how it's done today.
The soldier's got to lift a 100-pound projectile either from a bustle rack, a storage unit, or from the ground up into the feed tray. Then he's got to put the right charge behind it. He's got to first fuse the projectile, put it on the feed tray, put the right charge behind it, and then fire it. This does everything.
Patrol, weapon is locked and loaded. We're clearing the site.
5, 4, 3, 2, 1. Execute.
To see what the back of this howitzer can do in uploading ammunition and the stresses that's going to take, the physical stresses that's going to take off our soldiers is absolutely amazing. I didn't believe it before I came out here.
The NLOS cannon's automation means that it can put down a barrage of rapid fire on a scale that's never been seen before.
It's capable of holding up to 72 charges and 24 rounds. What used to take 21 minutes to fire now only takes 4.
All right, 4 rounds. Took about 8 or 9 seconds each round. Absolutely amazing. Soldiers couldn't do that without killing them.
Clear to station.
Gentlemen, choose your weapons. You have high explosive dual-purpose smoke, white phosphorus, and even smart precision munitions. And they can all be fired from the NLOS cannon. Select the amount of charge you require, then lock and load. The computer control system will do it all for you. It'll even set the fuse and fire the round. As you'd expect with the next generation of cannon, it's devastatingly accurate and smart. The NLOS cannon can track the projectiles once they're launched and make any corrections to subsequent shells seconds before they're fired to ensure that they hit the target.
So when it fires a projectile, it has a radar, a sort of radar on it that can track the projectile from gun to the apex of the trajectory, its ballistic trajectory, and determine where it hits on the ground, and we can make a correction off of that. Absolutely unbelievable.
I'm about to find out what happens when you make a big gun smart and build it into an intelligent, lethal network.
It's not an evolution, it really is a revolution in technology.
I've come to Yuma to see just how good the non-line-of-sight cannon really is. The combination of smart tracking and firepower means that the NLOS cannon can strike with pinpoint accuracy. This level of accuracy is needed to fight in tough urban combat situations such as Iraq.
I have infantrymen ready to kick in the door of an insurgent home. I can use an NLOS cannon with its precision munitions and its capability to fire precision munitions, and instead of having our infantrymen and our Marines go in there and clear room by room, which is incredibly high risk, I can put a 155 projectile on the roof of that building. There's nothing to clear but the munitions and the bodies.
The NLOS cannon uses a firing pattern called MRSI, or MRSI, but there's nothing merciful about it. MRSI stands for Multiple Round Simultaneous Impact. In the space of 60 seconds, the cannon fires off 10 rounds, all set to hit the target at the same time.
Why do you want the rounds in there at the same time? It's a thing called the popcorn effect. If I put 1 round on the enemy and he's got time, what's he going to do? He's going to take cover. And I can't acquire or destroy as much as I could with 4 rounds just hitting the ground.
The popcorn effect can be put to good use, especially when it comes to eliminating an advanced guard.
We're on the march to, let's say, Baghdad, and we're in an open desert environment, and you see an enemy artillery battery out there, an enemy tank formation, an enemy whatever formation out there, and they're scattered along the battlefield. I can go put 108 155 rounds on them, and I can virtually cover an enemy formation with artillery rounds. It really will demotivate them to fight us at that point. That's what artillery does. You know, there's a reason why we are called the King of Battle.
Kings of battle they are, but like strategic pieces in a chess set, the NLOS cannon is part of a bigger picture. The Future Combat System is designed to be flown to any trouble spot in the world. The Army of the future has to be light and fast on its feet. That means heavyweight pieces like the field cannon have to be substantially lighter.
Every ounce of weight that we can save by optimizing the design we're trying to do here.
The NLOS cannon has to weigh in under 20 tons. That's half the weight of its nearest rival. They've achieved this by using rubber tracks, which are half the weight of conventional steel tracks, cutting back the barrel to a third of its normal size, and using active defense systems in place of heavy armor. This active defense system uses a sophisticated set of sensors that allow it to see all around itself.
A system which has a 360-degree set of sensors, senses the launch of a rocket-propelled grenade, a tank round, a variety of munitions at the vehicle, locks onto it, tracks it, and then can either jam it if it's a guided missile or a guided weapon, or fire a projectile which will intercept it and blow the projectile out of the air before it hits the vehicle.
When this system hits its target weight and size, it'll be able to fit in the back of a C-130 aircraft. Then it can be deployed anywhere in the world to any battlefield within a matter of hours. Once in place, the NLOS cannon can be ready to fire in just moments.
When we're on the move and we receive a mission, the howitzer will stop and we can fire around within 30 seconds.
It's not just the speed of deployment that makes the NLOS cannon special. Thanks to its powerful engine, it challenges other howitzers for the land speed record.
It's not a weak engine. I mean, we can go about 55 miles an hour on a flat, hardball surface, and on tank trails, we can go upwards of 30, 35 miles an hour. That's fast.
The NLOS cannon is equipped with a powerful hybrid engine using both diesel and battery power. Diesel is used for dash, but the batteries are used for silent running when stealth is required.
Just the engine with the battery power, combining those two, you get a very fast dash speed capability, and also lets us operate the vehicle just on batteries. So in the stealth mode, we can drive for about 20 minutes with no engine on.
How quiet is it?
Well, if you're walking across the field, you wouldn't hear it sneak up behind you.
But what makes the Future Combat System unique is that the whole system is built to be intelligent. All the military hardware is networked, communicating real-time information on the battlefield.
Imagine if we took 700 vehicles that are networked so that they're all communicating with each other digitally, they're communicating with each other over FM wavelengths. Think of the connectivity we bring to that place and how much better we could support the operations that are going on over there and synchronizing those efforts.
This is the weapon of the future, and when the NLOS cannon makes its debut, it'll undoubtedly create maximum impact on the battlefield.
Leveraging those technologies for that future combat scenario. I mean, we're making our soldiers and our equipment more lethal, and that's what it's all about.
Next, how to clear bad guys out of caves. The fight to defeat global terrorism has taken the U.S. military to Afghanistan. It's a country where it's difficult to target the enemy because of its mountainous terrain and numerous caves.
HDBT is an acronym a lot of people use in the Pentagon that refers to hard and deeply buried targets.
Hard and deeply buried targets is exactly where the enemy was hiding in Afghanistan. You can't get much better shelter than from inside a mountain. No single weapon existed that could take out the long tunnels and deep caverns of these complex cave systems. Neither artillery nor conventional bombing had any effect. And although American troops were on the ground there, sending them inside caves would be a suicide mission.
It's a very confined space. Everybody knows when you're coming in. You're stepping right into the line of fire.
We wanted to come up with a better capability to defeat tunnels so that our guys don't have to go in themselves.
What was needed was a completely new kind of explosive device.
You need the kind of weapon that could generate sustained blasts so that by the time the blast reaches the target deep inside the tunnel, it's still of sufficient intensity to defeat that target.
The weapon they started to develop was a thermobaric bomb. Work on the thermobaric bomb continued at the Navy's main research center based at Indian Head near Washington, D.C. The head of development is Dr. Anne Duong. She had a personal interest in the development of the weapon.
I used to be a refugee. I came to the United States at the end of the Vietnam War when I was 15. So because of my background, I've always had a very deep compassion for the war fighters.
and showed me the laboratory where she and her team developed the thermobaric bomb. She has no qualms about throwing everything she has into future weapons projects.
I want to make sure that I do everything at least I can individually, personally, to contribute to the protection of this democracy and this freedom.
The mixture created to make the thermobaric explosive was specifically developed to be a cave buster.
Thermal means heat, baric means pressure.
To see how the thermobaric blast really works, the Defense Academy in Britain conducted a series of demonstrations. We brought fiberglass mannequins to the firing range to compare the effects of 3 different types of explosives. First, a traditional experiment placing 3 mannequins at short distances from some plastic explosive.
Blast actually does fall away very, very quickly from the center of the explosion.
Dr. Steve Murray is an explosives expert at Cranfield University.
What is surprising to many people is just how quickly it falls away.
Do we have range clear?
Range clear.
This is what 8 pounds of explosive looks like when it goes off. Our high-speed camera is running at over 4,000 frames per second. It clearly shows what happens to the 3 dummies.
The one that was nearest the actual charge itself has been absolutely completely shredded. But the ones that were further away are still pretty much intact. This is typical effective blast.
Impressive at close range, but plastic explosive is useless against a target deep inside a cave. Now, one of the most devastating mixtures ever devised, the fuel-air explosive. Our next willing victim is just 10 yards away from the charge.
This jar is going to be filled with a flammable liquid. It's not an explosive in its own right. And in the center of this is a high explosive burster. When that detonates, it's going to throw out the liquid into a big cloud. And the cloud will then cover this charge, which is going to go off sometime after the burster, when the cloud has actually covered the charge.
The results are spectacular. At 20 times atmospheric pressure, the mannequin is completely destroyed.
Typical blast damage, I mean, that has absolutely seen the pressure, the crushing effect of the blast wave. Just ripped it apart.
Although the fuel-air explosive is incredibly powerful, it needs a lot of air to ignite properly. So it's useless in areas like caves where there's simply not enough air for it to detonate. This is where the thermobaric explosive comes in. Unlike the fuel-air mix, thermobaric explosives don't need much air to burn. And when it burns for much longer, creating a much bigger blast wave.
The idea of these sort of enhanced blast or thermobaric effects is to attempt to make the blast last longer. Normally, it would be used best inside a building or a structure, but we're going to see it obviously outdoors and see the effect.
By now, we're running out of dummies, so we decided to play it safe and plant our last mannequin 15 yards away from the thermobaric charge. Here's the explosion in slow motion. Imagine this firebomb inside a tunnel. Our last mannequin is history.
You can see here, splitting, the crushing effect on that leg. The blast wave has actually crushed the leg. That effect works far better, actually, inside structures, buildings, tunnels, than it does outdoors.
The thermobaric device had been in development for a few years. The invasion of Afghanistan meant Anh Duong and her team had to suddenly deliver a working weapon in days, not years.
I got the call from the Pentagon. We were told to do something now. By the time we started the project, our warfighters were already in Afghanistan.
With no time to lose, the team had to finish the thermobaric bomb in just 67 days. The weapon was now ready for testing, and the caves of Nevada were the perfect test site. Tom Ward was ahead of the test program. How did they manage to deliver the bomb so quickly?
They were working just massive amount of hours to make sure this thing comes together.
We work night and day.
We knew how far and how fast we could push things.
Normally, a weaponization program takes 3 to 5 years because, you know, when you deal with explosives, you have to be extremely careful.
And we went right up to the edge of the limit.
And we knew that we would not have a second chance. This is it.
Lab tests are one thing, a live field test is another. To work properly, an F-15 fighter had to drop the bomb exactly at the mouth of a tunnel. There's no room for error.
While we had tested it on the ground in static test, the whole issue was during the whole dynamic flight is making sure that the weapon actually performed as intended.
10 seconds, get back.
The thermobaric bomb was guided by laser right onto the target.
Check line. Impact, switch signal.
The F-15 pilot hit the bullseye.
He dropped it, and it was a perfect hit.
It was an impressive feat seeing the thermobaric weapon fly into the tunnel facility and detonate. And you know that it's creating a lethal environment down that facility.
A high-speed camera in the tunnel captures the blast. The footage proved that the blast wave carried right through the tunnel, and the energy from the blast even exploded out the vents.
When the weapon went in, you saw the relief on everybody's face at the test. It was great.
The weapon performed exactly as expected.
Hooray. A relief, a great sense of relief.
The weapon was now ready to be deployed. From the caves of Nevada, 11 thermobaric bombs were shipped to Afghanistan, ready to be used in the Afghan mountains.
There was definitely an effect out there where folks understood and knew that they were not safe inside some of the tunnels these days.
I tell you, when you're strongly motivated, you could move Earth. You could make miracles. And that's what this team was able to do. We all saw what happened in 9/11, and we all wanted to do something about it. So everybody, voluntarily, there was that sense of urgency. We spent all these years working in science and technology. Here's our chance to step up the plate and deliver something to the warfighter.